and powers, which, again, you all already know for today. Tomorrow we'll be doing some stuff that your grade 9 teacher may have shown you or may not have shown you. I don't know. But everything we do today, you should already know. Okay? Just review. So let's have a go with this and see what happens. The first thing we are going to talk about is indeed powers. Powers are used, and I want you to highlight this, please, or underline it or something. Repeated multiplication. All right? That means that we are multiplying things over and over again. Okay? So 7 to the third is 7 times 7 times 7. At least one of you in this class, at some point in this unit, I'm going to say, what's 7 to the third power? And one of you is going to say 21. Right? Because you're going to think, okay, yeah, exponent 7, it's multiplying. 7 times 3 is 21. Okay, got it. One of you is going to do that. And that's okay. We're going to fix it. Right? The key to remember here, it is repeated multiplication. 7 times 3 is not repeated multiplication, is it? That's repeated addition. It's 7 plus 7 plus 7. This is repeated multiplication. Okay? And I am taking time to stress this because, as you remember from grade 9, there were about 5 things that you can do with exponents. We're going to add 3 or 4 more things that you can do with exponents in grade 10. It can get a little confusing trying to remember all those different rules. But it's not confusing if you remember that this is what we mean. We mean multiplication, repeated. Sorry, I wanted to get my pen circle back. Okay? If you remember that this is the basic concept with which you are working, you can't do anything in exponents wrong. If you remember this. Everybody cool? All right, so we're going to work with no calculators for a while, all right? We're going to do all this with our brains, where math should get done. I'm going to use colors here. You can use colors if you wish. It's up to you. The base. What in this situation up here is the base? The 7. Excellent. So I'm going to color him blue. I shouldn't assume it's a him. What is the base? You can answer this in a variety of ways. Somebody give me an answer to the question, what is the base? And it's not boom, 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 boom. One moment. Go for Myers. Yes. Okay. Eden, at some point, Ms. Thompson would like to see you in the counseling center for like 1 second. So you can choose when that is. If you remember all stuff about the basics of exponents, you could go now. It's totally up to you. Now, where was I? Mr. Core. What is a base? How can you answer that question? 2 hands went up. Wyatt, what would you say? That's the real definition of it. The base is the thing that is going to be repeatedly multiplied. Excellent. Carlin, were you going to say the same thing? Yeah. Excellent. Now, how else can you describe or define the base for me? Because there's what it is, which is what Wyatt said. It's the number that we're going to multiply 3 times. But it's something else, too. What does it look like? Carlin. It's the big number that we write on the line. Everyone understand that? Okay. So the base is 2 things. One, it is and I'm going to use the word term because it doesn't always have to be a number. Okay? The term which we repeatedly multiply. That's horribly written. Repeatedly multiply. That's what it is, And then what does it look like? It's the big number. I shouldn't say number. It's the big term. Everybody cool? Okay. Next thing, the exponent, which I'm going to highlight in green. The exponent is 3. Again, talk to me about what the exponent is. Again, there's what it is and where it lives. Those are two different things. What is it? It's 3. What does it mean?
How many times the base is being...
Right. The exponent is the amount of times we multiply the base. Frozen computer. Now, where does it live? It's what we call the superscript because it's above the line. That means we write it above the line. Okay. The whole thing is the power. It is a base and an exponent. And how do we read that? 7 to the third power. Except this guy gets a special name, right? Who remembers the name of that guy? 7. What is the 3? It gives us a special name. Cubed. 7 to the third is cubed. That's one special name. And 7 to the 2 is squared. And those are the only ones that get those special names. All of you know all this, yes? This is not news to any one of you. But there is something that I like to remind you of here, which is why there's so much white space. The base is anything directly left of an exponent. That's a simple sentence, right? Everybody can read that. Everybody knows what all those words mean. What is the... Obviously, 2 of those words are very important because I highlighted them, or I wrote them in capitals. But there is one word there that I didn't write in capitals that is super important. And it is what, Carlin? Directly. That word is super important. And here's why. I'm going to write that over here. X plus 7 squared. What is the base in that black expression? 7. Everybody cool? Okay. Really ruins the suspense when this happens. X plus 7 squared. What's the base? Jordan. X plus 7. Does everybody see that and understand what I mean? A great many of you will forget that. I'm going to do 2 more. What's the base? or on the screen, was negative 3 squared. And I asked, what is the base there? So while you are thinking of that, you've had enough time to think about it while I've made fun of my computer here. What is the base? You all sorted out? Sweet. What is the base in this one right here? Connor, what?
The base is negative 3.
Okay, Connor says the base is negative 3. Does everyone agree? Okay, you're all wrong. What's the base? 3. Why? Because what did I write over here? The base is what is directly left of the exponent, yes? Is that negative directly left of the exponent? No. What's the only thing directly left of the exponent? 3. How could I make that negative a base? I would have to do this. Everybody remembers that? Everything on that screen except for this should be old news to you. If it isn't, you're going to want to pay very close attention when we fill in this table at the bottom. Everybody cool? All right. Start filling in that table with your neighbor if you don't remember how to do it. I will warn you. This one is tricky. These two are tricky. These two are tricky. Start filling it in. You can talk to your neighbor. 2 brains are better than 1. We should do the first one as an example. Base is in the first one. 2. Exponent is 4. It looks like 2 times 2 times 2 times 2. And what does the word evaluate mean? Yeah, you guys like the word solve, but it just means what is the final product with no exponents. Now, if you get to a big one and you can't remember how to make your calculator do the big ones, just ask and I'll talk about it then. Just leave it blank and I'll remind you how to do it. Okay? Everybody good? Go. Knock this out of the park, please. And when you evaluate that, of course, it is 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. If you are not sure, either leave it blank or put a little star by it for one if it's one you don't remember. Good here. I already gave you the hint to that one. What's the base? 3. What's the exponent? 3. So what is repeated? 3. How many times? 3 times. But I cannot forget about that negative. What is 3 times 3? 9 times 3 again, 27. So the answer is 27, but The whole thing is negative. So our final answer is negative. Everybody good? Good. What's the base in the third one? Negative 5. What's the exponent? So what is repeated? Negative 5 times negative 5. The negative is repeated here. So I get an answer of positive 25. Everybody still good? 3 for 3? All right. Well, the first one I gave you, so 2 for 2. But we'll call it 3 for 3. What's the base? 8. Exponent 5. 8 times 8 times 8 times 8 times 8. Now you got to be able to use your calculator, right? Does everybody remember the button to do exponents? It's different on everybody's calculator. Does everybody know what theirs is? It's either x with a little y, y with a little x, x with a blank, y with a blank, or this little uppy pointy arrow thing, which is actually called a caret. It is one of those buttons. So everybody, please make sure you can find it on your machine. And it is what? Say it right. Don't say 5 digits. Tell me what the number is. Pardon me, Rihanna? Nicely done. Because in grade 10, we don't say 32768, do we? Do we? All right. Okay, how many 6s are there? 5. So what's the exponent? What's the base? What's the power? 6 to the 5th. What's the answer? 7,776. What about the next one? What's the power? The power. Negative 1 to what power? 7. The base is negative 1. The power is 7. What's the value? Negative 1. 10 cubed. 10 times 10 times 10. 1,000. Now, most of you probably, I shouldn't say that. There's a portion of you that probably in grade 9 never ever did a variable with an exponent. Is there any of you that are in that boat? Yeah, there will be some of you because it used to be part of the grade 9 curriculum and then they took it out of the grade 9 curriculum, but some teachers left it in the grade 9 curriculum because they knew that it was in the grade 10 curriculum. Okay? If you were in my grade 9 class, hey, Mr. DeVries, you have already seen a variable with an exponent.
Variable with an exponent? Impossible.
Math always follows the same rules, yes? So if the base is anything to the left of the exponent, what's the base here? X. And the exponent is 3. If the exponent, 3, means I multiply the base by itself 3 times, what goes here? X times X times X. Naughty. Triple X. Yeah, it's that movie with that Vin Diesel character in it. Isn't it Ice Cube now?
No, it's still Vin Diesel, but Ice Cube is
Ice Cube's in it now, I see. I don't buy Ice Cube as a secret agent because he's short and fat. I just don't buy it, right? That would be like Jack Black playing James Bond in the new movies. That would be stupid, right? That would be a bad casting decision. No, Connor, that would be dumb. Jack Black could do a spoof. He could be the new Austin Powers, were they to make another Austin Powers movie. So, can I evaluate this? No, why? Because you don't know what X is. It's variable. It could be 3. It could be 7.9. It could be 212, right? You can't evaluate it. This one, 2 times 2 times 2 times 2 times 2, which is what? Oh, what happened here? There's a negative. So what has to happen here? There has to be a negative out in front. So this would be negative 2 to the 5th, yes? Now wait for it. Is this right? Is the base here 2? Why? Because there's no brackets. What if I put brackets here? Will I get the same value? Why? The exponent is odd. So that negative is going to go negative, 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 negative. Every time it hits an odd, it's going to go back to negative, right? Because negative times negative is positive. A third negative would make it negative. But because the base is 2, there are no brackets. Everybody with me? All right. 9 is the only thing I'm given. How can I make positive 9 with an exponent? Pardon? I could do 3 times 3, couldn't I? Which would give me a base of 3 and an exponent of 2 and 3 squared, yes? Is there another way I could make positive 9 using 3's? I could do negative 3 times negative 3, yes? Which would mean the power would look like what? Negative 3 in brackets squared. So the base would be, what would the base be then? The base would be negative 3. And that would get me the same value. Everybody understands that, yes? That is a really key concept. That 3 squared is the same in evaluation as negative 3 squared. But it is different than negative 3 squared. Does everybody hear the different ways I say that? Okay. So here's another 9. How else can I make positive 9? 9 times 1. So 9 once. So what's the base? 9. What's the exponent? 1. What's the power? Just 9. Why? Because you never write 1 as a power. You guys. Carlin, you must have had a wonderful grade 9 teacher. He was probably stunningly handsome, funny, witty beyond belief. Good, wonderful taste in shoes. Balding. Oh, ties too, yeah. Sartorial splendor all the way around. Sartorial means dressing. All right. This one is a tricky one. What's the base? The base is indeed negative 4. What's the exponent? 6. What's the repeated multiplication? Negative 4, how many times? 6. Right? 6. Now, Carlin, that's a negative. It's repeated an even amount of times. So the answer is going to be what? Except why not? Because there's a negative out front. So in front of all this is another negative. So even though this is positive, that negative out in front makes our final answer negative. What is it? Negative 4,096. And this one's super easy. What's the base? What's the exponent? What's the repeated multiplication? 4 just exists, and it's 4. Everybody cool? Now down here at the bottom, I want to remind you of something, okay? Everybody look at this. Negative 5 squared is what? Wyatt? No. Negative 25. Negative 5 squared is what? Positive 25. Okay? Do something to remind yourself down there. A negative out in front means your final answer is negative. Everybody cool? Can we turn the page over? Everybody is good on exponent basics, yes? All right, now listen to me. You have seen all these laws before. I don't know, I cannot guarantee who showed you these laws before. I don't know if that person just said, this is what you do, or if that person actually showed you why it works. If you know why these exponent laws work, then exponents are super easy. If you memorize the steps, you're going to get confused. So I'm going to take a moment to talk about each one of these and why they work. Okay? And we're going to change things to use only variables. Everybody okay with that? Okay. So let's start. Multiplying powers of the same base. So x is just some base, yes? To the power of a, some exponent. Everybody cool? Then I'm going to multiply that by x to some exponent. All right? That's the rule. What do we do when we're multiplying? Who remembers from the 9th grade? Pardon? All right, see, so nobody's remembering. So let's change it slightly. If I had 2 squared times 2 to the third, what is 2 squared? Really, don't say 4. What is it really? 2 times 2, yes? Times, what is 2 cubed really? 2 times 2 times 2, giving us a total of how many 2's? 2 to the 5th. What is the connection between 2, 3, and 5? You add them, right? Does everybody remember seeing the red stuff in the 9th grade? Yes. So what's the rule? Now that we're in the 10th grade and our exponents don't have to be numbers, what is the rule? It is x, and what do I do with the exponents? A plus b. Is everybody cool with that one? And that always applies. Please notice a mistake that a lot of kids make. They see 2, they see 2, they see times, and they tell me the answer is 4 to the power of 5. That's an error, isn't it? All right. So you guys are smart kids. X to the a divided by x to the b. Rewrite that in another way. How else can we show division in math? As a fraction. This is the same as x to the a over x to the b. You guys are smart kids. If multiply is add, divide is the opposite of multiply. What do? Subtract. That's x to the a minus b. Now, just to make sure, let's remind you. 2 to the 4th over 2 squared. What is 2 to the 4th really? 2 times 2 times 2 times 2. What is 2 to the 2 really? 2 times 2, right? 2 over 2 is what? 1, so we don't have to count it, do we? Cancel. Cancel. What's left? 2 squared. And the relationship for 2 and 2 is subtraction. Remember, if you can actually explain it, exponents are easy. What's the third one? An exponent to an exponent. X to the a, all to the b. I want to ask a question about that before I go on. What is the base? X is still the base. Who remembers the rule there? X to the A times B. And then, of course, we're going to explain it. 2 cubed squared. What's the base here? 2. And what is happening to 2? It's being cubed, right? So what's that really? 2 times 2 times 2. And how many times is that happening? Twice. Because it's being squared. So I end up with how many 2's? 2 to the 6th. And the relationship is, of course, multiply. You're such a piece of garbage. I hate you so much. Is everybody good to there? Everyone should have seen this in the 9th grade, at least the stuff in red. Did you all? Excellent. Did you see a fraction base, which is this, x over y to the a? Did you see that in the 9th grade? Okay. So what do we do? Where does that a go? It goes to everything. Cool? So in the 9th grade, you saw this as this. 2/3 squared, which got you what? 2 squared over 3 squared, which got you 4/9. Right? Now, right there, I stop for a second. Because what messes kids up is all 4 of them apply all the time. Do you understand what I'm saying? So if I gave you, and don't write this down, I just want you to think about it. If I gave you this, x squared over y cubed, all to the 3rd power. Every law applies. So what do I got to do there? Where does that 3 go? According to law number 4. It goes to everything, right? But there's already an exponent there, so that power is being raised to a power. So what do? Multiply. So that is x to the 6th over y to the 9th. Can I do anything else there? Why not, Alyssa? Because they're different bases. Is everybody cool with that? All right. So now we start getting to some tricky stuff. An exponent of 0. X to the, oh crap, I want that in blue or black. X to the 0 equals what? 1. Why does that work? 2 squared over 2 squared. What is that really? 2 times 2 over 2 times 2, right? What else is it? It's division, right? So it's also 2 to the 2 minus 2, isn't it? So it's also 2 to the 0. And since that's the same thing on the top and bottom, same thing on the top and bottom, it's got to equal 1. Is everybody with me? Now there's something else I want to show you there, and I want you to write down what I'm about to write down. 2 cubed is what? 2 times 2 times 2, which equals 8, yes? 2 squared is what? 2 times 2, which equals 4, yes? 2 to the 1 is what? 2, which equals 2. What's happening here? 8, 4, 2. What's happening? It's cutting in half, right? I'm dividing by 2, yes? So what is the next logical step here? 2 to the 0, because that. Can I write 2 multiplied by itself 0 times? Is there anything I can put here? No, but my next logical step here is to divide by 2 again. So what do I get? 1. And that's going to happen every single time. If it's 3, it would have been 27, 9, 3, 1. Right? If it's 4, it would have been 64, 16, 4, 1. Everybody cool? Now, the only other thing I have to talk about when I have an exponent of 0, because everybody says everything to the 0 is 1. That's what you're taught, right? Every teacher has said that to you at least one time when you've been talking about exponents, yes? I have not, if you were in my grade 9 class, because it's not always 1, is it? What is negative x to the 0? Negative 1, because of that negative number. If you get locked into your head, everything to the 0 is 1, you're going to screw that question up. What is this? One sec. Longer than 1 sec. I wrote that wrong. What is this? Positive 1. Because that negative is part of the base. Does everybody understand that? Do you all understand why? Everybody cool? Yeah? Going once, going twice, going thrice. Alrighty then. Number 6. You also saw this in the 9th grade. X, y to the a. Doesn't that look exactly like law number 4? And in law number 4, the exponent went to everything, yes? So what do you think happens here? The exponent goes to everything. Do all the other exponent laws apply? Always. So, first of all, we'll prove it. 2 times 3 squared. That is 2 squared times 3 squared, yes? Which is 4 times 9, which is 36. Right? If all the exponent laws apply, and again, don't write this down. This is just to make sure that you honestly believe me and you're not lying to me. What is x cubed, y squared, squared? Don't write it down. Just look at it and think about it. All exponent laws apply. Would anyone like to volunteer their answer? Come on, one of you guys can do this. Alyssa? Perfect. Because this has to go to everything inside, but I remember that when I'm doing power to a power, I multiply. Everybody cool? All right. All of that, you should have at least seen. In grade 9, you should have done a lot of work with 1, 2, 3, and 4. Maybe you didn't do too much with 5 and 6. Number 7, only kids that were in my class can I guarantee that was seen. Most of you probably haven't seen number 6. 7, I mean. So let's do that. What would it look like? X to the negative a. right? What does that mean? Well, that means x is going to multiply by itself a negative amount of times. Does that make any kind of sense? Does it? It makes no sense, right? 2 squared, that makes sense. 2, and then there's another 2, makes a square, right? 2 to the 6th, okay, 2, 2, 2, 2, 2, great. How would you show 2 to the negative 6th? How could you write that? 2 times 2 times 2 times 2. Where does the negative go? Because it's not negative 2, is it? It's 2 to the negative 6th. Is everybody with me? It makes no sense, does it? So, let's talk about what actually happens here. Remember that chart we just made on the last page? We did 2 squared equaled 4 equals 2, right? And then we did 2 to the 1 equaled 2 equals 2 squared equals 4. I'm doing this wrong. There, 2 squared equals 4, 2 to that. And then 2 to the 0 equaled 1, yes? Because it's divide by 2 each time, right? So you guys are smart kids. What's the next logical exponent? What's the next number going down? Negative 1. So the next logical exponent is 2 to the negative 1, yes? And every time we go down a step, what did we do on the right-hand side of this chart? We divided it by 2. So 2 to the negative 1 must be, what's 1 divided by 2? 1/2. What's the next logical step? Negative 2. So what would that logically be? What's 1/2 cut in half? If I have 50 cents, which is half a dollar, and I cut it in half, what do I have? A quarter. What's the next logical step? 2 to what exponent? Negative 3. And what's the next logical fraction? What's a quarter divided in half? I cut a pizza in fourths, an eighth. Now you should be noticing a pattern, yes? What is that pattern? 2 squared is 4. 2 to the negative 2 is what? 1/4. What is 4 really? If we weren't lazy math guys, how would we write 4 properly? It would be 4 over 1, wouldn't it? So what happens when we go to negatives? It flips over. Does everybody see that? And when I flip it over, then it's 2 squared, isn't it? 1 over 2 squared. And that makes sense, doesn't it? Because that's 1 over 2 times 2. Everybody cool? So what's the rule? It becomes 1 over x to the positive a. Very few of you will have seen that in grade 9. Did anybody other than Carlin and Daniel see that in the 9th grade? Oh, Vicky, yeah, I taught you too. You've seen it? Okay. Everybody else hasn't. It seems really simple, yes? It makes perfect sense when you write it out in the red, right? There's only one thing that causes problems. What if I gave you this? 1 over x to the negative a. What would that one be? Just use your heads, talk to your neighbor, see if you can figure it out. Something in blue there isn't allowed. What would it be? What would it be? This blue one. Because I'm not allowed to have negative a. I can't leave negative a there. So what's the answer?
X to the power of a over 1.
X to the power of a over 1. Would I ever write that 1? No. So it would just be x to the a. I just flipped the fraction. Everybody cool? Okay. Then what would this be? The next logical step. X over y to the negative 2. Or wait, sorry, to the negative a. What would that be? All exponent laws apply. There's two ways to do this one. Who has a guess? And by the way, I know some of you are probably stressed. This is where we're finishing today, and I'm not giving you any work to take home. Because you have a test tomorrow on trig. So what would this be? Where would that negative a go? To everything. So I would have x to the negative a over y to the negative a, yes? Are negative exponents allowed? So when x to the negative a was there, where did it go? We reciprocated it. So it went down there and became positive. Where did this one go? Up to the numerator and became positive. So what's the shortcut? I could have just flipped this to y over x and made the exponent positive. Everybody good? We're going to stop there. I'm not going to give you any work on exponents. Only learned one new thing today. Tomorrow is a trig test. What do you need for your trig test? You need a calculator. Is your phone allowed? No, because it's a test. And I only have 2 to lend out. Should you use a calculator that you're not used to? That would be a mistake. You need your formula sheet if you cannot remember SOHCAHTOA. What are you going to write your test with? A pencil. Right? What are you going to write on your test? Your name and your score from the review yesterday, which was out of 30? 30? Okay. Do you have the whole period tomorrow? Yes. If you run out of time, I will give you some exponent work to do tomorrow. I mean, not if you run out of time. If you run out of test and have time left.